Hi folks, and thanks Jeff. It's good to hear your kind of point of view there on technology. It's fantastic, and some really good tips there for people for the future, and thanks for sharing that. Today I'm going to look at quite a few things coming up from a Microsoft point of view and generally in the tech industry point of view. But I think the first thing to think about is about jumping the curve, right? And I've got a good example here, and what I mean by that is really trying to think innovatively. When you think about the Netflixes of the world and the Amazon who's up next of the world and the Microsofts of the world, you've always got to think about things that are new and different. Okay, so an example of that would be years and years and years ago, well before I was alive, you used to have farm ice in Canada. This is an example here, a nice picture in black and white. People farming ice in big warehouses, and they could do that in the winter. Now, when they wanted to innovate to try to make more money and make more people kind of wealthy, and also try to kind of support food production and storage of food, they tried to innovate by just bringing in horses and carts to get the ice quicker to different countries. So it's really, really important, and different places, rural areas and things like that, really important to think that, innovation and jumping that curve is different contexts. And they wouldn't have thought about actually really jumping the curve to think about the refrigerator and people making their own ice. So what we see is a lot of people, when you're thinking about ideas and trying to really innovate, thinking in their domain too much, not thinking outside the box. So one of my tips is to try to think outside the box and think into the future a little bit more on how things could be changed, not just doing small incremental changes of things, but actually really trying to change things at a large scale, right? So what are the things that are driving us? What are these engines to help us jump that curve? Three things that I'm going to call out here. There are a lot more than this, but these are three things that I see in my role. Cloud, and that's big data and artificial intelligence specifically. So people using more data and using artificial intelligence to make predictions on that data, using automation, like Jeff said earlier on, and about robotics, but about day-to-day things, about AI, the things you see in Netflix, so it's selecting different programs that you might have watched based on the genres that you enjoy, or the items that you might see on the Amazon website, or the searches you might see on Google, or the things you're interested in you might see on Facebook. Those algorithms are really driving a lot of the things we do, sometimes in good reasons and ways, and sometimes in bad. But we've seen a lot of resurgence of big data and data being used now with artificial intelligence. The second pillar that really interested in from an enterprise point of view is security and privacy. So you should look into that a little bit as well if there's something you're interested in terms of cyber security and some of the threats. When you look at what the president of the US said this week about where the threats are, all about cyber, all about technology, right? So really, really important to think about security and privacy. Because when we're using more big data and AI, then we need to make sure that we're ethically using that data and we actually keeping that data secure and respecting privacy. And then the third engine, which is one of those out there engines, but we just currently creating that now with a couple of other companies, is quantum computing. So really, really interesting to kind of start thinking about those areas as well. So that might all seem a little bit far-fetched for you and thinking, well, what are you cracking on about here, Dan? How does this actually work in reality? So I'm going to share with you some case studies on what we're actually doing now using some of this technology, right? So the first one is in Darwin Harbour. We're actually using facial recognition and cognitive services to actually identify fish stocks in the harbour in Darwin. Now, you can't just jump in and count fish in the harbour. So we get little drones there that actually take footage, and you can actually see what type of fish are in there, and you can count the fish because you can't jump in the water in Darwin because of the sharks. So that's a really good, Australian example of where some of this technology and big data can be used. Another example is where we're teaming up with Indigenous traditional owners of the lands in Kakadu, and we're using AI and drones to rehabilitate parts of the national park up there, so we can actually check bird life and other areas of the wetlands and really try to monitor what's going on in the Kakadu National Park. Another one, similar technology here, is around teaming up for turtles, we called it, and that's about using our cloud and AI tools to monitor nests of turtles, because there's lots of feral animals in the Northern Territory, which in Cape York area, which eat in turtle eggs, and therefore pushing the turtles into decline. So we're actually using AI and drones to monitor and track predators around there. Another example is where we're using some of the cognitive technology and big data to support police services in New South Wales and in Western Australia. Because if you think about it, when you catch a criminal these days, their digital footprint is really important. They may be communicating with their fellow criminals via WhatsApp, via Facebook, via SMS, via the internet histories, via they're leaving digital footprints everywhere, via their credit cards, via transactions that are happening, via location services, even Instagram posts and things like that, where they're checking into where they are. So you need to correlate thousands and thousands, if not millions, of data points to really track evidence. So we're working with the New South Wales Police and the police in Western Australia to do projects around that. And as well as some of these kind of public sector kind of areas, we're also doing things around some fun things like the NBA in the US and the NRL, where we kind of digitizing content there to enhance fans' experience. So there's a lot of stuff going on around there, and poignantly, I suppose, in the current time with COVID. I know you asked a question earlier about vaccines and things with the Johnson & Johnson guy, but it's also about trying to look at health pathology and transform medical testing and patient care with cloud data and artificial intelligence. So we're doing a lot with New South Wales in there. These are just some examples. We've got heaps and heaps of them. They really make it real, and I think that's the important thing. It's not about the technology that we're making. So it's not necessarily that you want to work for Microsoft, it's the fact you want to use those technologies to do something to help you in your trade. So you might want to be a programmer and work with those tools to help the health industry, or to help vets, or to help the police, or things like that. So it's about your domain experience. Now, when we're thinking about the cloud and also jumping the curve, let's connect these things together, right? So one of the first things I talked about there was the cloud and my 3 engines of change, right? So this is a cloud, right? It's data centers in companies like Microsoft or Amazon or Google. Now, there's nothing too special about that, but what is special is you can start thinking about sustainability, because people are pushing, your schools and universities, you're pushing lots of the on-prem infrastructure into the cloud, into our cloud, into other providers' clouds as well. So that means we can look at the environment, we can look at sustainability, and we can scale for you on there. Now, where that's actually happened, and a good example, right, would be where we are looking at Xbox. Now, this is an example of jumping the curve. There's currently the console wars, if you wanted to call it that, where people are going, okay, this Xbox and this PlayStation, and you might sit on those kind of fences yourself, and based on the console you've got and your friends play. But what we're doing is putting Xboxes into the cloud, which means that you don't need to go out every Christmas and buy an Xbox. You can run the most powerful Xbox from the cloud. And as and when new technologies become available, and faster technologies and more processors and more RAM, that'll be pushed into the cloud for you. So you don't need to go out and buy hardware. So that is a leap. And sometimes companies make gambles on these. Sometimes they're a success, sometimes they're not. But would you want to be playing the latest games on extremely fast internet over extremely powerful computers without having to buy hardware all the time? So that's where we sit in. And if you think about that, I think it's really important that you are all discerning users of technology, because unless this is the same if you're using an Android mobile phone or an Apple mobile phone or a PC or a Mac or Chromebook or whatever, it's important that you're choosing those devices for your own purpose, right? And thinking about that as technologists. There's no point, just because I work for Microsoft, it doesn't mean that I should just focus on Microsoft stuff. I should look around and say, well, what else is happening in the industry there? Because that's how you kind of skip that innovation curve and jump to the next level. So you've got to keep looking around and keep seeing what people are doing. And based on cloud and Xbox and this xCloud technology, this is a really good example of Microsoft Flight Simulator, one of our first games that we created from Microsoft Studios. Now that uses the power of the cloud to bring real-time geographic information system data into the game. So if you fly in and there's a storm, say in the east coast of the US at the minute, then you can fly and get real-time data and fly around that, through that, and see some real geographical information in there real time. So that's where the power of the cloud comes into it, because you're using the processing power of the cloud to generate that content for that game. So that's a really interesting component there. Now I'm going to show this video. My audio keeps cutting out, but I'm going to press this. So when we're thinking about 3D and mixed reality, okay, and those games, we've created a piece of hardware called HoloLens, which is a way to kind of connect the cloud and an end user computing device together to create, and this isn't virtual reality, it's mixed reality, where you can see through these glasses and it'll present stuff over the top of reality. So I'll play this and hopefully you can hear the audio when it comes through. Now that might sound a little bit cranky, I suppose, and think, wow, that's a little bit futuristic, because you lots of used virtual reality, I suppose, and seen and experienced mixed reality with your mobile phones, and maybe you've got Oculus Rift and things like that. But when we're looking at it, we're looking at an enterprise level as well. So it's really consumer focused. So that means people who could just buy it, you can buy one of these things for Christmas. And if you've got a Windows 10 laptop and you're running it now, you can actually go to 3D Paint. You can create a 3D object, you can import those objects, you can create those, export those into Maya, you can develop those into Blender, you can then actually view that in mixed reality all directly inside Windows 10 or 11 coming up. So you can really use that mixed reality and create things yourself, right? So it's about that element of creating experiences for people, linking into games, but also linking to real things. So where we have seen success in HoloLens is in the military, in hospitals, in education, where you can actually open up bodies and actually see hearts and digestive systems and things like that. So it's about the application of that technology. So we create that platform, and that's, I suppose, one of the things why I like working for Microsoft, is that we create the platform and everybody else builds this amazing stuff on top of it. So looking forward to see what you could build with HoloLens. So that's another nice driver when we're talking about, I suppose, that next level. We've got cloud, we've got some of these things around mixed reality and technology around 3D. So the next element that I'm going to talk about is quantum computing. Okay, so this is really important. There's a couple of companies in the world creating that, and you may know what quantum computing is already, right? But this is going to be, and I hate using the word game changer, but this is going to be something that's really going to push forward lots of aspects of the world, but also give us some problems and headaches around the areas of like security and cryptography and things like that. So classical computing, which we've always kind of been taught around and through, is binary, ones and zeros, right? Electricity either flows through a circuit or it doesn't. And it's just simple zeros and ones, right? If you use redstone and things in Minecraft, same thing. But with qubits and quantum, that means things can be in a two states at one time, right? So that's really the kind of building block of what quantum theory is. And there's lots of explainers online. I've got a picture of Schrodinger's cat. This is a classic thought experiment from Ernst Schrödinger, a scientist, a very famous scientist around Einstein's time, and they used to pit each other against each other with different thought experiments. And his one to explain quantum was if you put a cat in a box with a vial of poison and you close the lid on the box, then the cat is alive and dead and in two states at the same time. Now that in our environment seems preposterous, right? You can't have something living and dead at the same time, but at the quantum level, you can have things in two states at the same time, and when they're observed, the point of the thought experiment is when you open up the box, then you observe the cat either being one of those two states, right? There's some great explainers online about this, but what I'd kind of draw your attention to is a quick example. If I was going to be trying to find this light bulb on the screen here, and I was using classical computing, I'd go around every single one of these pathways until I found the bulb, right? I'd go around top one, the next one, the next one, the next one, and keep going and going. And you might be doing that with your eyes now, going around finding all these dead ends until you find the right one. That's what classical computing does. But what quantum does is it'll do all of those simultaneously. So that means that you can get to that answer very quickly, and that's going to have a profound effect on things in terms of speed of compute. Now we're teaming up with Station Q in Sydney. That's been open for the last 3 or 4 years now, where we've got a team of engineers across Microsoft Research globally and in Sydney itself, working on our quantum computer, and are also developing a language called Q#. So that's, if you wanted to learn quantum computing, that's where you'd start. So we're really trying to, and other companies are trying to democratize quantum computing, because this is going to change things fundamentally. So let's have a quick look at how that might change. Let me just put my audio on again.
Houston, we see you. We have a go. Over.
We talk about quantum computing, it's a completely different game.
Quantum computing will enable us to solve problems that currently take longer than the lifetime of the universe in seconds, hours, or days.
We completely reconceive the space in which we do computation.
Quantum computing is like going from crawling to going to a different planet. It's different.
It's only natural that we would want to use the world's most powerful device to combat the world's most challenging problems.
We could attack global warming.
Security.
What are the boundaries of machine learning?
Fighting diseases. The possibilities of quantum computers are endless. Microsoft has the best and the brightest working on this problem.
It's really happening. Progress is very fast. But we're building a quantum computer.
What the world wants to know is what happens when we turn the machine on.
What problems will be solvable with a computer that computes in 1 billion parallel universes at the same time?
So hopefully that gives us a bit of an idea of what quantum is and what that impact that's going to have. So we're thinking about when we're talking about jump that next curve. Now, where do you start? Okay, I've talked about some of those engines. Jeff earlier on talked about some of those engines. You've got a couple of presenters today talking through things as well. So, it's important that you don't just listen today and just kind of say, well, that's interesting. Actually start to do something about it, right? So where can you start? So start with your own learning. You can identify roles, skills, and learning paths. There's some websites on the screen here. Microsoft Learn is where we send all of our customers and ourselves. We've got to do training. Everybody at Microsoft gets a day off every month to do training to make sure that we're all on top of our game with all the technology, and that's everybody. So everybody has to have technical certifications, whether that's somebody in marketing, they need a cloud certifications. We've got people who are doing finance, they need to get their cloud certifications. Lawyers, they need to get a cloud certification. So it's very much about being technically skilled in whatever role you're at Microsoft, and you can do that. You don't need to wait for your school to give you the courses. You don't need to wait to go to university, because a lot of the time to develop curriculum, it takes too long. And this technology has been created now, and often learning yourself is actually the quickest way to get it. And like was said in the last talk as well, write your own blog, get your own LinkedIn experience, really start to drive your own industry knowledge, I suppose, as you're going through, because you are the future and it's yours to make. Okay, so hopefully that's given you some idea of the engines that we're thinking about from a Microsoft point of view. And now we got some time for some Q&A.
Yeah, thank you, Dan, for your amazing presentation. I have a few questions. Can you explain who initiated AI?
AI was, that's a really interesting one. I've got an AI podcast if you're interested, and we talk about the history of AI. The AI has been around, I suppose, from the dawn of time when we started to talk about stories. When you even think about things like Frankenstein, the human condition has always wanted us to develop people that we can interact with, and things and robots that will help us in society. So science fiction has developed a lot of that through Isaac Asimov's writing, for example, and the writing of Mary Shelley and Frankenstein, even, like I said. So, historically, the humans and the human condition, what makes us human, have really wanted us to drive us to develop things that think like ourselves, to make people or objects that can be intelligent. And it was driven from that. And then there was a Dartmouth conference in the US in the 30s where lots of the minds came together and thought we could break this down, right, by mathematically creating algorithms to do what humans could do. And then that science got developed on. We went through an AI winter then after that, when there was quite a few wars on and there was a bit of emptiness. But now with the advancements of computing and speeds of RAM and memory and CPUs and all that kind of stuff, and cloud computing, it's really pushed AI even further, so we can do more than we ever thought we could with computing. So that's why we're seeing more AI with cognitive services like those examples I showed earlier on. So it goes back, very, very far historically in the human psyche. Hopefully that helps.
Is there currently a bigger emphasis on certifications and projects than degrees or diplomas?
That's an interesting one. I think yes is the answer. The certifications are very, very important because they're moving quicker than degrees. Often you will see entry levels into tech jobs and jobs generally needing certain qualifications in that particular field, and the traditional thing is a degree or higher, but actually that isn't really the case if you've got skills in that particular domain, right? So I'd say if you're not sure what you're doing, then you stick into education as long as you can. But actually, if you've got an idea what you want to do, then you can actually focus on that particular area. So if you wanted to do IT and go into artificial intelligence, then you can do courses, short courses, TAFE courses, on technology to drive that through. So I don't think the traditional model of degrees getting in is always standard, even though some companies still put that as a bar of entry to get in, even if it just controls the maturity of employees coming in, so people are a little bit older. But yeah, I think skilling is very, very important, and you need to do both in an ideal world where you can crack on with a degree or a TAFE course, and then also skill yourselves up in a specific domain that you're interested in.
Are there any Microsoft Australia career opportunities, such as student or entry level, at the moment?
Yeah, we have big intern program. Careers.microsoft.com has got all the stuff you might be thinking about there. You can have a look for. We have intern programs which is just currently opened. So the easiest way in is to well, one of the ways in, sorry, is to go and become an intern. So people in the third year of their degrees, and that could be a degree in anything. It could be a degree in English. It could be a degree in law. They can become interns in Microsoft. So I interviewed a load of those last year. We had about 500 applicants, which is great. And then also, if you wanted to be a domain specialist, then you can do the certifications, okay? And then go into specific things. So if you're interested in artificial intelligence, for example, or cloud computing, then you could actually learn that, get the qualifications in that, and then come in and apply directly for some jobs based on your knowledge and qualifications.
Yeah. Where do you see mixed reality going into the future?
I think it's going to be basically embedded in everything, in all mobile devices, and more cloud compute, so more connections with stuff in the back end. So at the minute, a lot of it is about putting a dinosaur in your room and kind of moving around and seeing that. But I think it's going to be more, what we're seeing it anyway, is around remote assist, connecting in with our Dynamics platform in the back end, connecting in with real-time geographic information. So in a military context, not just looking at a plan of, say, a battlefield, but then sending real-time telemetry from satellites, for example, to the cloud, to your headsets. You can see real-time information happening. So more cloud-enabled mixed reality is what I see going.
What is the most important thing a high school student or a university student should know when they're just thinking about their career?
Oh, that's a great question. I think it's about following your passion. And I know this sounds really rubbish, but you follow the things you're interested in, because we've got doctors working for us, we've got legal people working for us, and other tech companies. Follow the things you're interested in. The important thing for me is you being discerning users of technology, right? So just like I do struggle generally myself when I'm looking at people and they go, yeah, I'm an Apple phone user, when people don't look outside the box and say, well, what is Android doing? What is, you've got to keep on top of your game. You've got to keep learning. You've got to keep interested and motivated. And you've got to say, okay, well, I work for Microsoft. That's great. You've got Amazon coming up next, one of our competitors in cloud space. And, I look at what they're doing all the time and say, hey, that's pretty neat, the stuff they do in space and whatever. That's great. And it's about looking around and being discerning users of technology and understanding the technology, because that's where the key is. So using those applications, because just because Microsoft make cognitive services for facial recognition, it doesn't mean we're going to make the facial recognition and come up with those problems to solve from the real world.
Yeah. What is the toughest thing you had to face in your career?
Wow, that's a tough question. Geez, I suppose it's the balance for me, and I think this is the same as everybody on the call today around COVID and things. I think it's very easy not to shut off when you're in tech. You're always learning. You have to think about your well-being, and the toughest situations that I faced have always been when you forget about that balance, or you drop that balance and your health goes, or you get family issues, because everybody has got things that goes on. You have arguments at home, you might be ill, somebody might be ill or in hospital, and you're trying to work at the same time. I think the toughest problems, and it's a constant occurring one with everybody, and you all know this in the hybrid work and hybrid learning at the minute, is balancing work with family and health. And I think that's something that it's a constant challenge for me, and probably one of the ones that I'm constantly trying to work on every day.
Yeah, I think we only have time for one final question. If you could do things all over again, would you choose the same path for yourself? Why and what would you change?
Yeah, no, I choose the same path. I went into education, I became a teacher, and then I went into IT. I did an IT degree. I think, yeah, no, honestly, I think we're going to be changing jobs so many times. I've changed my job multiple times through my year. I think it's about being resilient, do what you enjoy. You can't change anything, right? There's no point in looking back. And I think you just got to go through and give every day your best chance and your best shot. That would be my advice, because your careers will change. What you're thinking you're going to do today isn't really what you're going to be doing in 5 years and 10 years. You've just got to be resilient to be able to make that change. So, don't be afraid to make those choices. And think big, right? If you want to become a rocket scientist, you can. If you want to be involved in AI, you can. If you want to be a quantum theorist, you can. Nobody should be writing themselves off because they haven't done well in school or haven't done anything. You can be whatever you want to be and be ambitious.
Yeah. Well, thank you, Dan, for your amazing presentation.
No problem at all. Thank you. Thanks for having me, everybody, and have a good day.